All right, look. There's our cubic function. All right, the first part says, using the zero product property, find the roots, zeros, x-intercept, solutions. Those are our synonyms. Okay. Knowing the zero product property, what are my x-intercepts? What are my numbers? What's the value x-intercept? What's the solution here? X equal?
1.
Yes? I'll do it by hand in a second. What would this one be? It's okay to be wrong. Very good. And what is this one? Okay, if you don't remember, why is that? The zero product property says you can set the binomials equal to 0 and make them separate equations to solve. So there's my 1, x plus 4, set it equal to 0. You get x equal to -4. And then x plus 2, subtract, oh, can you even see it? Oh yeah, I wasn't even looking up. X equal to -2. Okay, so that's why I get my x-intercepts. Okay, you're gonna place them in, you have to put them in negative to positive. So if I was to put them in the most negative to the most positive, -4 is here, -2, and then +1, correct? In terms of the x-axis, left to right, yeah? Okay, so -4 here, -2, and +1. So far, so good? C. Okay, now, if what we found are roots, zeros, yeah. X-intercepts are solutions. If these are x-intercepts, what is my y value if this is my x-intercept? No, you guys know, if you guys are looking for your x-intercept, what do you let equal 0? Y. So this is 0. 0, 0. I know, you guys know, it's just once it's like shown to you differently, you guys like question yourself. Okay, so that means if I'm looking at a graph, right? So say here's my 0, here's my y-axis, here's my x-axis. This is not the graph I'm going to graph though, okay, you guys? What that means is if these are x-intercepts, that means the graph crosses here, here, and here, right? Isn't that what it means? Okay, so we have to find other points. So I'm going to just use a marker here because I know I'm going to have a lot of writing going on. So just to kind of help you guys color code. Okay, so look. These 3 came from my binomials. And that's what it looks like visually. Yes? Okay, now you need to graph this. Like, where is it coming from? Is it coming down below and shooting up and coming back down because it looks like a roller coaster? Or does it bounce off and then come through and then bounce off? Like, you don't know how it looks. So you need to find numbers. Okay, give me a number to the left of -4. And right. You don't, now remember, you got a cubic here. Don't get too fancy. Just go 1 digit over. And even the 1 digit, sometimes it grows so exponentially that you're like, yeah, it doesn't fit on my graph. So then you'll get like half a point. Okay, input, output. If I want -5, okay, I gotta move this over because it's not gonna balance. You just substitute it. So see how there's a parenthesis, and that's x, -5, subtraction 1, right? You're just substituting.
All the x's?
Well, yeah, is it x? It's x, right? And then, wait. -5. Make sure you're doing it right, you guys. I cannot make mistakes. That's just bad. Okay, so far so good? And so what's my y value? -18. Okay, so if this is my very messy graph, right? If this is y and this is x, can I just make -18 down here and pretend? Okay, so then this is -5. We'll eventually graph it pretty. There's my point. So now I know my graph is coming through Here. Okay, I wasn't supposed to do that. Here, right? Okay, so now you guys are always gonna pick the halfway number. In between two intercepts, go half. And the reason why is I'll show you tomorrow. I'll show you the proper way because we're talking about local maximum, local minimum. But you gotta use calculus to solve it correctly. We're not in calculus. So how do we kind of make a whatever graph? Go the halfway number. So what number is between -4 and -2? -3. And so substitute -3. So backtrack. And what do you get? +4. Yeah? Like I said, you guys are really good with this. Okay, so then -3, 4 is here. And so now you're kind of moving back down. We'll graph it nice so it'll look good, okay?
For the next one.
Oh, okay, so from -2 to 1. So if here is -2, -1, 0, +1, how many units apart is it? 1, 2, 3. What's half of 3? 2. And what is that? 1.5. So that's your midpoint. So go 1 unit and a half. And what number is that? Right. So this should be -0.5. And the reason why is tomorrow I'll show you properly with calculus and I'll show you on Desmos. The number matches beautifully. You guys are not expected to do calculus in here. So how do we do it for im3? Your graph is an estimation because we make you find the half number. But your graph will never perfectly match Desmos because we're not in calculus. Fair? Okay, so put in -0.5 and you get, wait, can you guys see? Yeah. And you get -7.9, -8, yeah? Okay, so -7.8. But if you guys went -8, you would not get like docked for that. Because again, it's an estimation.
So we're not graphing. So
I'm gonna give you I'll give you the pretty graphs tomorrow. But right now, since I'm building it, it's not gonna look perfect. Okay. So -0.5 is, if that's 0, that's 1, that's -1. Well, that's a little far, but okay, -0.5. And what am I at? -8. And so here's my point, and so now it comes back up, and now you just need to see it shoot off, and so what do you want here? 2. And so George is like, I want to get out of here. You're so like the way you're giving your answers. Okay, and you get 24, and obviously it really, really shoots off, so whatever, you're way up there, right? So 2 will make it way up here, 24. Okay, that's how you graph them. But again, it's an estimation. We're going to stick to one little bit at a time. I'm going to give you guys these little graphs. Why can't I grab enough, you guys? What is wrong with my name? So tomorrow we'll do it again, and I'll show you guys what the calculus, and I'll show you what the Desmos. But if you just stick to this for the other 3, you do really, really well with it. Okay, you're welcome. And then we'll make the graphs pretty.
wait, how do you?
Oh, wait, there was no negative. Oh, you mean for the -0.5? Because you want them to have, okay, since we're not in calculus, the way we try and get the most accurate estimated graph is we try and find that halfway number between -2 and 1. say like, I don't want to do that, can I just go -1? I mean, technically, since my -1/2 is an estimation, your -1 is an estimation, so it's not wrong because neither of us are doing it.
So it's $277, but with the...
All right, I need to stop the video. I just realized it's going still, and I don't know if anyone's going to be talking, so let me just shut this off.